Alright, thank you so much for coming to my YouTube channel. What you are able to see on the screen is what we are going to discuss in this video. So as you can see, we have 5 questions that we are going to discuss. Alright, so you can see we have 5 questions that we are going to discuss. The first 2 questions are coming from indices. So you need to recall in the previous video where I explained laws of indices and how they can be applied at various stages when you're solving a question involving indices. You can pause the video and just review laws of indices so that we can be on the same page as we will be solving these questions. We also have other 3 questions which will do with logarithmic functions. You also may need to review laws of log functions so that we can move at the same pace. The way questions will be solved in this video may be jumbled, but they'll have their own solutions. Alright, so get yourself ready, let's get started. The first question we have is what you saw as the first one on the previous page of the video. So we have 16 to the power x minus 5, open bracket, we have 4 to the power x, close, plus 4 is equal to 0. Now how can you solve this question? This is where we're going to apply laws of indices. What this means is that you look for a number that you can write in index form so that you can solve your question. So in this one that we have, we can write 16 to the power x in index form, and when we do that we are going to have 4 to the power 2, right, and x outside the brackets as the power as well. Now we know that mathematically we can multiply a power inside the bracket as long as it still remains a power, and also outside the brackets as long as it still remains a power. And that's what we've done. We've multiplied x inside, right, so it becomes 4 to the power x, and 2 we multiply it with 1 outside, it becomes 4 to the power x inside the brackets to the power 2 outside the brackets, which means we can now let 4 to the power x is equal to y. Now if that, then what we have as 4 to the power x, we can substitute it by y, and if we do that we're having y squared minus 5y plus 4 is equal to 0. Now we can solve this by factorization method. We can see that our sum in this case is -5 from the quadratic equation that has been formed, right? So our sum is -5, and the product we have, which means a times c, is 4, right? Now let me show you that in case you've just forgotten. What I'm saying is, okay, let me just use a different color. What this question means, the new quadratic equation, our coefficient here in front of y is 1, that is y squared, and our product, we need to multiply the first coefficient, which is a, multiplied by the constant c. So we have 1 times 4, which is c. We still get 4, right? So this is our product, and our sum is -5, right? So we need to look for 2 numbers, which when we add, we are going to get back our -5, which is right here. Then when we multiply them, we are going to get our product, which is 4, which we get by multiplying the coefficient of y squared, or whatever variable we're going to have. It can be x squared, w squared, a squared, it doesn't matter, as long as is your coefficient to the highest, sorry about that, as long as it is what you have. Alright, so okay, sorry about that. Let's just let me just erase that so that you're able to see clearly. Okay, alright, so that's what we have. Okay, good. Let's proceed. Okay, so we have our sum, -5, and our product. So the two numbers that you can use, you can pause this video and try to guess. You know that okay, let's solve it from here on top because of the space. Again, we still are using the same quadratic equation. So the two numbers we can use are -4 and -1. Look at this, your -4 and -1, right? When you multiply -4 times -1, you are getting +4, right? Which means these two numbers are giving you back your product, right, which is 4. Again, when you add the two numbers, that is -4 plus -1, you are getting -4. So these are two numbers that we can use. So multiplying them with our variable that we are using, which is y, we're going to have that's -4y minus y. Now we can do this by factorization, which means we can divide the expression into 2 and find the variable that is common on one side and also on the other side. So when we look at the first expression, which is y squared minus 4y, we see that we can factorize y. We put it outside the brackets. Then we are going to have 1y there, which is y to the power 1 minus 4. And we have -1 is what we can factorize here. We are going to remain with y minus 4 because when you multiply -1 times y, you are going to have -1, negative y back, and -1 times -4, you are going to have +4 here, right? That's why we have used a negative here. Alright, so what this means is that we can pick just one of the contents of one bracket which has the same thing, and what is outside the brackets we group them in one bracket. That's factorization. And this now means we can equate each bracket to 0 one at a time. So if we do that, we are going to have y is equal to 1 or y is equal to 4, right? Now remember something here. We said y is equal to 4 to the power x. Now we have found that y is equal to 4. What this means is that, so 4 to the power x, right, what we have here, now we substitute on y with the value of I we have found. This time is 4, so you put 4 there, right? Now 4 is in power 1, right? Now according to laws of indices, if the bases are equal, you can equate the powers to solve for the value of x, and that's what we have done, which means our x is equal to 1 when we equate the bases, right? I mean the powers. Now we've also found that y is equal to 1. Let's see how we are going to deal with that. We know that y is equal to 1, which means 4 to the power x is equal to 1, right? Now you may be surprised to say I have not equated this expression to 1, instead I've equated it to 4 to the power 0, right? By now you must be familiar, or you must have known, that any number or variable to the power 0 is same as 1, right? So what I've written here, 4 to the power 0, is same as 1. So it means I have not changed anything. I have equated 4 to the power x to 1, right? So we can see that the bases are equal, right? Which means x is equal to 0, right? If there is any question, you can still comment or anything. All right, thank you so much. Let's proceed. We look at the second question. The second question, we have 3 to the power x plus 1 is equal to 9 to the power 3 to the power x plus 1. Also here we are going to use laws of indices, which means we can look closely on both sides of this mathematical statement and see if there is any number that we can write in index form. And yes, there is. Our right side, we can write 9 in index form, that is 3 to the power 2, again to the multiplied by the already existing power, which is x plus 1, right? So what that means is that when we multiply 2 throughout the power, we have 2x plus 2, which is 3 to the power 2x plus 2, as you can see, right? Okay, let me just change the pointer there so that we can see it nicely. and let me use this. Okay, so this is where we are, and you can see that the bases are equal now, so we can equate the powers. If we equate the powers, you're going to have x plus 1 is equal to 2x plus 2, which is the power on our right side, and x plus 1, which is the power on our left side, right? Now what this means at this stage is that you need to add both sides of your mathematical expression, which we have, with the additive inverse of positive 1 and additive inverse of positive 2x, so that they can be on one side of this equation which we have. So if we do that, we can multiply. If we multiply the left side by the additive inverse, which is of positive 2x, we have x minus 2x, and when we add, sorry, not multiplication, okay, we are not multiplying, we are adding. So if we add on both sides with the additive inverse of positive 1, we have negative 1, which is 2 minus 1, which means if we subtract, we are going to have negative x is equal to 1, which will give us x is equal to negative 1. All right, that's all. We can proceed now and look at some log questions. So we need to solve for x in each of the following as well. Now here you might need to pause the video and go back, just try to go through lots of logarithmic functions and then come back so that we can be on the same page. So let's get started. We know that when you're adding two logs, the first expression we have log of x minus 4 inside the brackets base 10 plus log of x minus 1 base 10 is equal to 1. We know that by laws of logarithmic functions, this can be multiplied, right? Because they have equal bases. I mean, they have equal log with equal base, which is base 10. We can just use log 10 and then we multiply there, right? And we still equate to 1. Now next, you may recall that if we have log of a base b is equal to r, where r is any positive real number, this can be written as our base to the power r. R becomes the exponent, and we equate this to a, right? So we want to apply the same thing here. Okay, this is just one laws of logarithmic functions which you may need to remember. So we apply the same property to the expression we have here. So this time our base is 10, right? Right, so we have our base 10 to the power 1, because our real number, which is acting as a positive real number, is 1. So we are 10 will be to the power 1. Then we equate this to the product of what we have inside the brackets, which is x minus 4 and x minus 1. So if we do that, what I mean is x minus 4 inside the brackets, x minus 1 inside the brackets is equal to 10 to the power 1. So we have just applied the property. And what that means is that we need to equate, or we can expand. We need to expand, right? When we expand the brackets, we can form a quadratic equation again, which we can solve by factorization. And you can see here that this time our sum is negative 5 as well. Now our product is negative 6, right? Remember, your coefficient this time is 1, so 1 times your constant, which is negative 6, you get negative 6 as your product, which means your sum is this number in between, right? Which is negative 5. So you look for two numbers. You see that if you use negative 6 and positive 1, this can give you your sum and your product back. So if we say negative 6 times positive 1, you are going to have negative 6, which is our product, as you can see. And if we add negative 6 plus 1, we are going to have negative 5, which is our sum. We are going to get that sum back. So we can factorize, and if we factorize there, this is what we are going to have. and we can group what is outside the brackets in one bracket and pick one from the common brackets. This is what we are getting, and we can equate it to 0 so that we can solve for x, and this is what we are getting. Alright, so let's now look at this other one. Again, here we know that under logarithmic functions properties, we know that this is an expression we have on top. Okay, we can add both sides of this logarithm equation with the additive inverse of positive log of x minus 1 base 10, or someone may decide to use log of x plus 2 base 10, right? So if you do that, you are going to have this expression. Again, you know that when you are adding, when you are subtracting two logs of the same base, again you can divide them, and this is the property trying to remind you to say, if we have log of a base b minus log of c base b, we can use just the common log, which is log base b, and then we divide them. So what we are going to get when we apply, we are going to have x plus 2 as our numerator divided by x minus 1 log, which is log of this expression base 10 is equal to 1, right? Again, here where we have reached, despite having a fraction inside the brackets here, we are going to apply this property we applied here, right? So we identify our base. Our base is 10, so 10 to the power r, which is 1 in this case. Then we equate this to the fraction x plus 2 over x minus 1. So if you do that, you are going to get this expression. That's if we do cross multiplication, we are going to have 10x minus 10 is equal to x plus 2. What that means is that you now add both sides of this expression with the additive inverse of x and also negative 10. You are going to get this expression, and now you can subtract, and this is what you are getting. Hence x is equal to 4 over 3. When you're dividing, you get 1 to the 1 remainder 1 over 3. All right, thank you so much. Let's proceed and solve the last question. So as you can see, I mentioned at the beginning of this video, the questions have not been answered according to the way they were arranged at the outset, but every question is solved and they have their only solution, so you can just try to rearrange them. Thank you so much. Let's solve the last one. Even here you need to remember laws of logarithmic functions, as you can see, and let's see what's happening next. So we know that we have log 25 minus log 125 plus log. Now here I want to pay attention, you to pay attention here. Look at what we have here. What we had on top is half, right? We have half there, and 625 log base 10 625. Now according to laws of logarithmic functions, half can be raised to be the exponent of 625. Now what that means is that we want the square root of 625, right? And this is why it has been written like that. And you can see here we have 3, right? Our numerator, which is 3 log 5, right? So 3 will be the exponent of 5. Now that means we are going to have 5 cubed. Now 5 times 5 times 5, you get 125. Try to confirm that. All right? So what we are getting, if we do this, we apply again. We know that when we are subtracting two logs, we divide them, and addition we multiply, right? And that's what you can see. We found the square root of 625 is 25, and we have the bottom 125 as our numerator, as our denominator. So we can divide here, right? We know that 25 can go into 125. That's 5 times, right? So if we do that, we are going to have this expression with our denominator log 125, Still we know that 5 can go into 25, which is 5 times. And to simplify this, remember we are simplifying and not calculating for the value of x. So thank you so much for watching. Don't forget to subscribe to this channel for more videos like this one.